Hello everyone, we are going to continue lesson number 7 variation. In this video we are going to study inverse variation. When there are two different quantities with an inverse variation, when one quantity increases, the other one decreases. For example, when you are traveling to a particular location, as your speed increases, the time it takes to arrive at a specific location decreases. If you decrease your speed, the time it takes to arrive at that location will increase. Now let us take another example. As the number of rows increases, the number of students in each row is decreasing. Here, if you take the product of number of students and number of rows, the product is a constant. In this example, it is 240. If there are 240 students in standard 8, if we make 6 rows, then there will be 40 students in each row. Now, if the number of rows increases to 24, then number of students decreases to 10. Here we see that when one quantity is increasing, then the other related quantity decreases. This kind of relation where when one quantity increases, a related quantity decreases is called an inverse variation. Inverse variation is like a seesaw. When one quantity increases, a related quantity decreases. Now let us see the statement of inverse variation. The statement x is inversely proportional to y can also be expressed as there is inverse variation in x and y. If x and y are in inverse proportion, x multiplied by y is constant. Assuming the constant to be k, it is easy to solve a problem. If x varies inversely as y, then x multiplied by y is constant. X inversely varies as y is written as x proportionate to 1 upon y. X is equal to k upon y, or x multiplied by y is equal to k is the equation of variation where k is the constant of variation. Now let us study one more example. Number of days required to build a bridge varies inversely to the number of workers. As the number of workers increases, number of days required to build would decrease. Now, let us solve the first sum from practice set 7.2. The information about the number of workers and number of days to complete a work is given in the following table. Complete the table. More the number of workers, then less days are required to complete the work. You can see over here number of workers 30. Days required to complete the work are 6 days. Number of workers 20. Days required to complete the work is 9 days. More workers, less days are required. Less workers, more days are required. It means number of workers and days vary in inverse proportion. So let us solve this sum. Let number of workers be m, number of days be n. Therefore, m inversely varies to n. Therefore, m into n is equal to k. K is constant of variation. Now we are going to first find out the value of k over here. So to find out the value of k from the table, we can use these two values, that is number of workers 30 and days required to complete the work 6 days, or you can take number of workers as 20 and days required to complete the work as 9. You will put these values in this equation and find out the value of k. So put m is equal to 30, n is equal to 6. This is given in the table. You can even take the other value. M into n is equal to k. 30 into 6 is equal to k. Therefore, k is equal to 180. Therefore, the equation of variation is m into n is equal to 180. We are going to use this equation and find out the remaining values from the table. So first sum, n is given to us as 12. M we are going to find out. M into n is equal to 180. M into 12 is equal to 180. M is equal to 180 upon 12. We'll divide and see what answer we get. 12 ones are 12. Remainder over here is 6. This 0 will take down. 60. 12 5s are 60. So your answer over here is 15. Therefore, m is equal to 15. Now, second, m is equal to 10. N we are going to find out. M into n is equal to 180. 10 into n is equal to 180. N is equal to 180 upon 10. 0, 0 get cancelled. Therefore, n is equal to 18. Now, third, n is 36. M we are going to find out. M into n is equal to 180. M into 36 is equal to 180. M is equal to 180 upon 36. 18 ones are 18 twos are. Over here we have 10. So 2 ones are 2 fives are. Therefore, m is equal to 5. Now we'll complete the table. We'll write these values in this table. When n is 12, m is 15. When m is 10, n is 18. When n is 36, m is 5. Now we are going to solve the second sum from practice set 7.2. Find constant of variation and write equation of variation for every example given below. First example, P inversely varies to Q. If P is equal to 15, then Q is equal to 4. Let us solve the first example. P inversely varies to Q. This is given. Now you know that in case of inverse variation, the product of two quantity is constant. Therefore, P into Q is equal to K. K is constant of variation. Now, in this equation, we are going to put P as 15, Q as 4. Put P is equal to 15, Q is equal to 4. This is also given to us. So, over here, P into Q is equal to K. P is 15 into 4 is equal to K. We'll multiply these two numbers over here. 4 into 5, 20. 4 ones are 4 plus this 2 is 6. So answer over here is 60. 60 is equal to K. Therefore, K is equal to 60. The constant of variation is equal to 60. Therefore, the equation of variation is P into Q is equal to 60. So over here we have got the constant as 60 and this is the equation of variation. P into Q is equal to 60 is the equation of variation. Now we'll solve the second example. Z inversely varies to W. This is given. Now, in case of inverse variation, the product of two quantities is equal to constant, that is K. K is constant of variation. Now, in this equation, we are going to put value of Z as 2.5 and W as 24. Put Z is equal to 2.5, W is equal to 24. Write that equation. 2.5 into 24 is equal to K. We'll multiply these numbers over here. 5 4s are 20, 5 2s are 10 plus this 2, 12. 2 into 4, 8. 2 2s are 4. 0, 8 plus 2, 10. 4, 5, 6. Put the decimal point 60. So 60 is equal to K. Therefore, K is equal to 60. The constant of variation is equal to 60. Therefore, the equation of variation is Z into W is equal to 60. Constant 60, equation of variation. Now let us solve the third example. S inversely varies to square of t. So S inversely varies to square of t. This is given. in case of inverse variation, the product of two quantities is constant. Therefore, S into T square is equal to K. K is constant of variation. Now, in this equation, we are going to put S is equal to 4 and T is equal to 5. Put S is equal to 4, T is equal to 5. Write down that equation. So 4 into 5 square is equal to K. 4 into 25 is equal to K. Therefore, K is equal to 25 into 4 is equal to 100. The constant of variation is equal to 100. Therefore, the equation of variation is S into T square is equal to 100. So, over here, constant we have got as 100 and S into T square is equal to 100 is the equation of the variation. Now let us solve the fourth example. X inversely varies to square root of y. If x is equal to 15, then y is equal to 9. So let us solve. X inversely varies to square root of y. This is given to us. You know that in case of inverse variation, the product of two quantities will give you the constant. Product means multiplication of the two quantities will give you the constant K. K is constant of variation. Now in this equation, we are going to put x as 15 and y as 9. So put x is equal to 15, y is equal to 9. We'll write down the equation first. Now we'll put the values. X is 15 into square root of 9 is equal to K. 15 into square root of 9 is 3 is equal to K. Therefore, K is equal to 45. The constant of variation is, or you can write, is equal to 45. Therefore, the equation of variation is x into square root of y is equal to 45. So over here we have got the constant as 45 and equation of variation is x into square root of y is equal to 45.